Diana Nauf is sitting the test of her life. At just 45 years of age, in a few minutes, she'll find out if she has the debilitating and incurable disease Alzheimer's. Using a remarkable technology called brain fingerprinting, her every thought is triggering an electrical response and being analysed by a computer. Surprisingly, this breakthrough in Alzheimer's detection owes its existence to advanced forensics. In America alone, nearly 100,000 crimes are committed every night. A whole industry of forensics, police, lawyers, judges and jurors go to great lengths to establish truth when investigating crime. But the law sometimes gets the wrong man. For every innocent suspect wrongly found guilty, there's a guilty suspect erroneously found innocent. It seems truth can be a highly subjective issue. The problem for a suspect is that when there's compelling evidence against them, simply stating that they're telling the truth is subject to the judge and jury believing them. That was until brain fingerprinting. Dr. Larry Farwell believes he may have discovered an infallible method to obtain the truth. It's well known that the brain can be monitored for electrical activity whenever a part of it is used. It lights up in a millisecond when we remember an event, something Farwell calls the aha moment. The technical term is the P300 murmur response. Farwell realised he could use this as a powerful tool for lie detection. Brain fingerprinting reads this brain activity. Participants are shown specific details on screen about a crime and respond if they recognise the details. If the accused has no knowledge of the crime, the brain will not trigger a P300 murmur. There will be no electrical activity. If guilty, the brain will light up like a Christmas tree, even if the accused has lied. So now it's my turn for a little brain fingerprinting. And the apparatus is surprisingly simple.
This headband will pick up the electrical signals from the brain.
How many sensors has it got on it?
Well, it has three main ones for three different parts of the brain. And then there are two references here to get a neutral point, and there's a ground, and then this one picks up the eye movement.
The crime I'm to be tested on was real, a vicious murder. Importantly for the test, I'm given some key details, but not all. Well, I'm in the hot seat. All strapped in, connected up. I'm about to be grilled over whether I was involved in a crime. The innocent have nothing to fear, right? Is it hot in here?
So, Anna, the crime that we're testing you on here is a murder, a double murder, that took place in 1991 in Edmond, Oklahoma.
Now, I know the crime was committed in Oklahoma, so when prompted about that, I click yes. At the same time, my brain has an aha moment, and the sensors pick up the electrical activity of my memory. Because I know nothing about this crime other than what I was told, I click Don't Recognise when other facts are shown to me, and the sensors back me up by not showing a spike. If I were guilty but trying to lie, I'd click no response each time, but my brain would be lighting up with memories. My clicks would conflict with what the sensors are picking up in my brain, and that signals a lie. Well, that was anything but pleasant. It's actually quite chilling knowing that any of those words up there could be related to the murder scene. And when they came up again, I thought I might have got the answer wrong the first time. I don't think I've ever been to Oklahoma. Let's check my results. So what's the verdict?
Well, we presented three types of stimuli. The details about the crime we told you are represented by this line. You have a very clear P300 murmur in response to that. You can see it clearly here on the screen. You recognize those details. The details about the crime that we didn't tell you, you don't get this P300 murmur response to those. So clearly, you weren't there.
Good. That's what I thought. Brain fingerprinting has nothing to do with your emotions. Unlike a polygraph, it cannot be cheated and has been ruled admissible in US courts. Farwell's biggest success to date was in early development of the technique. He was invited to brain fingerprint inveterate liar and suspected murderer James B. Grinder, seen here taking the test.
So my job was to figure out which story matched the story that his brain told, which story matched the information stored in his brain. And the result was the story that matched his brain was a story that had him committing the crime. He turned out to be a serial killer and was put away for life in the state of Missouri.
Criminal investigation isn't the only area that can benefit from brain fingerprinting. Because the technology gauges recognition in the brain, it can be used to test for mental disorders like Alzheimer's. And that's where Diana comes back into the story. She isn't yet showing signs of Alzheimer's, but she has a family history of it. Her grandmother was diagnosed all too late, when the family found her wandering around her house 3 days after the death of her grandfather. Not without some trepidation, Diana is on her way to Dr. Farwell's to test for Alzheimer's. Well, Diana, the brain fingerprinting technology is being used to detect early Alzheimer's, and you're going to have the test. How do you feel about the possibility of a positive test result?
You know, the great thing about new technology is that it can help us answer questions. We just have to be ready to hear what the answer is. I'd rather know than not know. I think that's it.
There is no cure for Alzheimer's, but Diana reasons if her brain shows early signs of deterioration, she can try known methods of stimulating the brain. For example, even just keeping the brain active to ward off the onset of the disease. You're a bit nervous?
I'm a little anxious.
Okay, let's see how you go. The Alzheimer's test uses the same principles as used for convicting criminals. The machine is looking for signs of brain activity. Diana is quizzed on her reaction to simple common phrases and facts which she should know. The machine measures her response time and can tell in an instant if the brain is suffering memory loss.
Okay, Diana, very good. We're finished. Now I'll analyze the data.
Dr. Farwell is once again looking for the aha moments of the brain. If they occur soon after Diana sees a phrase, her brain is functioning correctly. What do the results show?
Well, in the forensic application we did earlier, we want to know if people know something or not. So when you flash something that's significant to a person, their brain gets an aha response. When we're testing for Alzheimer's or early stage of Alzheimer's, we show people things that they ought to recognize, and we see whether the brain says aha or not at that time. So from the computer analysis of the figures here, we can tell by these numbers that your responses to all of these are clearly within the normal range.
That's a relief.
Good news.
It is, that's a relief.
Brain fingerprinting does have its limitations as a tool against crime, as you still have to find your suspect first. But being able to exonerate innocent people and help in the early detection of Alzheimer's will make it an important technology for the future.